In today's lesson, we will discuss another important rule for finding the derivative of functions in order to build on what you have already learned. Well, you know how to use the power rule. We have y equal to x to the power 4. You know, dy by dx equal to 4x to the power of 3. That's the simple power rule. Now, what happens if you have a function like y equal to 2x plus 5 raised to the power of 4? You see, this is no longer a simple x. This is a function of x. We are now raising that to the power 4. How do we use the power rule in here? That is where the chain rule comes in here. Now, how do we adapt this in order to make the chain rule? Now, what we do is, we take this quantity and call it equal to a single quantity, like, let's call it equal to u. In other words, let u be equal to 2x plus 5. Well, what does that happen then? Then our original expression becomes y equal to u to the power of 4. Alright, how do we find the derivative of this? Now remember, this will be the derivative of y with respect to u. Because y equal to u to the power of 4, we can find dy by du. Is that right? Because our y equal to u to the power of 4, we can now find the derivative of y with respect to u, which is dy by du, using the simple power rule. What is the derivative of u to the power of 4 with respect to u? Will be 4u to the power of 3. But we are not looking for dy by du. We want to find dy by dx. How do we find dy by dx from this dy by du? Well, we can do actually a very simple mathematical manipulation. Look at this. We want to find dy by dx. We know dy by du. So, in order to get dy by dx, what all we need to do is multiply dy by du by dx. Is that right? Look at that. Du and du will go. We will get dy by dx. Now, where do we get this du by dx? Well, from here, look at this. We have u equal to 2x plus 5. We can find the derivative of u with respect to x. Alright? If, let me write it over here. U equal to 2x plus 5. What is du by dx equal to? Well, du by dx is the derivative of 2x with respect to x is 2. The derivative of 5 is 0. So du by dx equal to 2. Now, let's put it all together. Dy by dx is dy by du, which we have here, multiplied by du by dx, which we have here. And so, we would say dy by dx equal to 4u cube, that is dy by du, multiplied by du by dx is 2. But remember, we don't have a u in the original expression, and therefore, to produce our results, we need to now replace this u by this quantity. What is our u equal to? 2x plus 5. So our result will be 4 times 2, 8, times u cube. U is 2x plus 5 raised to the power of 3. And that is our final result. Now, it looks a lot complicated, is that right? But it is a very simple process. All right, let's go to the next screen and see how it can be simplified. Now, let me show you how the process can be sort of simplified. Now, what we did is took this quantity out and called it equal to u. Is that right? So we said u equal to 2x plus 5. And what did we do then? We found du by dx, the derivative of that u with respect to x, 2x plus 5. Now, the derivative of 2x plus 5 equal to 2. And then we used the original expression. We found our dy by du because we said our y equal to u to the power 4. Now, when y equal to u to the power 4, we found dy by du equal to 4u to the power of 3. And we combined all together, we said dy by dx equal to dy by du times du by dx, and that will be dy by du. What is dy by du? 4u cube times dy by du by dx is 2. And we arrived at this relation, 8 times u cube 2x plus 3 to the power of 3. Well, I promised you that I'm going to make it a little simpler. Well, what I'm going to do is, when I have a quantity like this, I'm going to put my hand up there. Let this be called y equal to this quantity raised to the power of 4. So, let me take all this off and let's deal with this as a quantity raised to the power of 4. And then we apply the power rule to that quantity. Now remember, whatever quantity is there, that will remain in there. Now, can you apply the power rule? Let's say dy by dx equal to, apply the power rule to this quantity. How? It will be 4 times 2x plus 5 raised to the power of 3. So, let this be a quantity. Apply the power rule to it. 4 times 2x plus 5 to the power of 3. Now, once you do that, what all you need to do is identify that quantity one more time and find the derivative of that quantity. Multiply by the derivative of that quantity. What is the derivative of 2x plus 5? The derivative of 2x plus 5 is 2. So multiply that by 2. Now look at that. That would be 2 times 4, 8 times 2x plus 5 raised to the power of 3. So you can see a lot of writing we had earlier has been reduced to these 2 steps. How? One more time. We have a quantity raised to the power of 4. So treat this as whatever inside here is raised to the power of 4. Use the power rule for that quantity. So dy by dx is, use the power rule for that quantity. 4 times 2x plus 5 to the power of 3. And now we are not finished. You've got to multiply with what? The derivative of that quantity. Derivative of 2x plus 5, which is 2. And that will give you the derivative of our original expression. Alright, let me give you another one and see whether you can do that on your own. Okay, we have f of x equal to x squared minus 2x raised to the power of 6. F of x is x squared minus 2x raised to the power of 6. Well, what is f prime of x equal to? Now, what did I say that you do? Call the quantity that is raised to the power of 6. This is the quantity. So apply the power rule to that quantity. What will be the derivative there? That will be 6 times x squared minus 2x raised to the power of 5. But you cannot stop there, because it is not x, it is a quantity, it's a function of x. So what do we do now? Multiply now with the derivative of that quantity. Can you look at this quantity and tell me what the derivative of that is? Derivative of x squared is 2x, and the derivative of minus 2x is minus 2. So the derivative of x squared minus 2x is 2x minus 2. The derivative of f of x now is f prime x equal to 6 times x squared minus 2x to the power of 5 times 2x minus 2. And if you notice, we can factor out a 2 from there. So that will be 6 times x squared minus 2x to the power of 5 times 2 times x minus 1. Is that right? And now these two numbers multiply. That gives you 12 times x squared minus 2x to the power of 5 times x minus 1 is the result. So one more time, the simpler method to use the chain rule is when you are given a quantity raised to a power, apply the power rule to the quantity and then multiply it with the derivative of that quantity. Okay, let's try another one. Alright, let's take this off and let me give you another function. F of x equal to sine cube x. Sine cube x. Now remember, sine cube x means the quantity sine x raised to the power of 3. Let's write it that way. So f of x is sine cube x means the quantity sine x raised to the power of 3. So that's our f of x. How do you find f prime of x? What's the rule that we just discussed? Well, we said apply the power rule to that quantity. The quantity is sine x. So applying the power rule will give you 3 times sine x to the power of 2. And now what do? Multiply with the derivative of that quantity. What is the derivative of sine x? The derivative of sine x is cos x. So multiply with cos x. So our result is now 3 cos x times sine x to the raised to the power of 2 is sine squared x. That is the result. 3 cos x sine squared x, or 3 sine squared x cos x. Alright, we should be able to do this kind of simple chain rule problems without a lot of trouble. Let's try another one. Y equal to tan to the power of 4x. Remember, it means tan x raised to the power of 4. Alright, let me find dy by dx here. What do? First, apply the power rule to the quantity. What's the quantity here? Tan x. So, applying the power rule, we get 4 tan x to the power of 3 is tan cube x. So, we applied the power rule, 4 tan cube x. Is that enough? Multiply it with the derivative of the quantity. What is the quantity here? Tan x. And what is the derivative of tan x? The derivative of tan x is secant squared x. Remember, you need to have this derivative at the tip of your tongue. The derivative of sin x is cos x. The derivative of cos x is negative sin x. The derivative of tan x is secant squared x. What is the derivative of secant x? The derivative of secant x is secant x tan x. So always review these derivatives, write them down as many times as you can. So if y equal to tan to the power of 4x, dy by dx equal to 4 tan cube x times the derivative of tan x is secant squared x. Alright, one more. If y equal to cos squared x, what is the derivative of that? Dy by dx equal to, apply the power rule, you get 2 times cos x, is that right? The power now becomes 1. 2 cos x times the derivative of that quantity. Derivative of cos x is negative sin x. So that will be negative 2 sin x cos x. Alright, how many of you can give me a double angle identity for this? What is 2 sin x cos x? Very important identity here. 2 sin x cos x is sine of 2x. So this will be negative 2 sine of 2x. Okay. Always review those trigonometric results. Do you remember the derivative of a function like this? Y equal to square root of x. Well, if you don't remember, let's quickly get it. Square root of x is x to the power of 1/2. And now you can do it by using the power rule. Dy by dx equal to power rule 1/2 times x to the power of n minus 1, 1/2 minus 1. And that will be 1/2 x to the power of negative 1/2. And what does that become? X to the power of negative 1/2 is 1 over x to the power of positive 1/2. So that will be 1/2 times 1 over x to the power of positive 1/2. And what is x to the power of 1/2? X to the power of 1/2 is square root of x. So that will be 1 over 2 square root of x. And I told you some time ago that these results are important and you must remember it. If y equal to square root of x, then dy by dx is 1 over 2 square root of x. If y equal to square root of t, then dy by dt equal to 1 over 2 square root t. Similarly, if y equal to square root of p, then dy by dp, derivative of y with respect to p, is 1 over 2 square root p. That's a result that is very important. And let's now use this in the chain rule form and see how we can find the derivatives of square root quantities. For example, how do we find the derivative of this? F of x equal to square root of x squared minus 4. Now remember, I gave you the concept of a quantity. Here we have the square root of a quantity. Now what's the quantity here? X squared minus 4. Now what you know is that the derivative of a square root quantity, in other words, if you have u equal to x to the power, if u equal to square root of x, then du by dx equal to 1 over 2 square root of x. So, if this is true, then how do we write the derivative of the square root quantity? F prime of x will be, use the same rule for this quantity. What will that become? It will be 1 over 2 square root x squared minus 4, 1 over 2 square root of the quantity. Now what do? Multiply it with the derivative of that quantity. What is the derivative of x squared minus 4? So I'm going to say times d by dx of the quantity x squared minus 4. So we apply the rule for the derivative of a square root quantity. If u equal to square root of x, du by dx is 1 over 2 square root of x. If f of x equal to a square root quantity, f prime x is 1 over 2 square root of that quantity times derivative of that quantity. And that will be 1 over 2 square root x squared minus 4 times. What is the derivative of x squared minus 4? The derivative of x squared with respect to x is 2x. The derivative of 4 with respect to x is 0. So that will be simply a 2x. And 2 and 2 cancels. Our results therefore will be x on the numerator divided by square root x squared minus 4 on the denominator. Alright? Let's practice with another one. Alright, look at this now. F of t equal to square root of 2t squared minus 2t plus 1. We have a square root quantity. How do you find the derivative of a square root quantity? It will be 1 over 2 square root of that quantity times derivative of that quantity. So it will be f prime of t equal to 1 over 2 square root of that quantity, 2t squared minus 2t plus 1, times derivative of d by dt of 2t squared minus 2t plus 1. So again, f of t is a square root quantity, square root of a quantity. The derivative will be 1 over 2 square root of that quantity multiplied by the derivative of that quantity. And what is that equal to? That will be 1 over 2 square root 2t squared minus 2t plus 1 times, that is a dot there, times, what is the derivative of 2t squared? What is the derivative of 2t squared minus 2t plus 1? You should give it to me quickly. Alright, it will be 4t minus 2, is that right? So that will be 4t minus 2. So that's the numerator now. A 2 can come out. So that will be 2 times 2t minus 1 is the numerator. And 2 times square root of 2t squared minus 2t plus 1 is the denominator. And finally, we cancel those two t's, those 2's, and that gives you 2t minus 1 over square root of 2t squared minus 2t plus 1. And that is our final result. I think this is now relatively simple, is that right? Okay. How about this? Y equal to square root of tan x. Square root of a quantity. The quantity is tan x. So what is dy by dx equal to? The derivative of a square root quantity is 1 over 2 square root of that quantity multiplied by derivative of that quantity, d by dx of the quantity is tan x. So once again, the derivative of a square root quantity is 1 over 2 square root of that quantity times the derivative of that quantity. And that gives you 1 over 2 square root tan x. Alright, tell me, what is the derivative of tan x? The derivative of tan x is, alright, secant squared x. So that will be multiplied by secant squared x. And finally, we can write secant squared x on the numerator and 2 square root tan x on the denominator. Okay. Now, how about if I give you one that requires the chain to go to another link? This is just 2 links. If I give you one that has a third link, one more link, let's try that. Okay. Suppose I give you something like y equal to square root of sine cube x. Y equal to square root of sine cube x. Now why has this got one more link? Because we have a square root quantity and the quantity is a power. So it involves one more link. Alright, how do we find dy by dx here? Dy by dx equal to, remember, the derivative of any square root quantity is 1 over 2 square root of that quantity multiplied by derivative of that quantity, d by dx of sine cube x. Alright, that will be 1 over 2 square root sine cube x multiplied by, what is the derivative of sine cube x? Well, apply the first chain rule that I gave you. That will be 3 sine squared x times the derivative of sine x, that is cos x. Look at the 3-link chain. Now, one more time, the derivative of sine cube x. Here you have a quantity raised to the power of 3. So the derivative of a quantity raised to the power of 3 is 3 quantity squared times the derivative of that quantity. Derivative of sine x is cos x. So the derivative of sine cube x is 3 sine squared x times the derivative of sine x is cos x. So what does that become now? That will be 3 sine squared x cos x all over 2 square root of sine cube x. Alright, can you simplify this? If you look at this, sine cube x, now look here, square root of sine cube x can be written as sine squared x times sine x, is that right? Square root of sine cube x is square root of sine squared x times sine x, and that can be written as sine squared x can come out of the square root, it will become sine x, and the sine x will stay inside the square root. In fact, square root of sine cube x is this. So let's replace that. That will be 3 sine squared x cos x all over 2 times square root of sine cube x is sine x times square root of sine x. Alright, and you can see one sine x and one sine x cancel there. And what is the final result that I can write? That'll be 3 sine x cos x all over 2 square root of sine x. Alright? Try and practice this one more time on your own. Alright, how about this? Y equal to sine of 5x. Well, if it is y equal to sine x, we have no problem. The derivative of sine x is cos x. What is the derivative of sine of 5x? You can see that is a quantity there, sine of a quantity. Well, we can use the same concept there. The derivative of a sine quantity is cosine of that quantity times derivative of that quantity. In fact, we are calling this 5x equal to u, that u is our quantity. So we say if you have y equal to sine of u, then we can write dy by dx as cos of u, then you got to multiply it with the derivative of u times u prime. In other words, the derivative of sine of a quantity is, the derivative of a sine quantity is cos of that quantity times the derivative of that quantity. Now that will be cos of the quantity, that will be cos of 5x times the derivative of 5x is 5. And that gives you your final result as 5 cos 5x. One more time. If the derivative of sine x is cos x, the derivative of sine of 5x is 5 cos 5x. Alright, now tell me, if y equal to cos of 2x, what is dy by dx equal to? The derivative of a cosine quantity is negative sine of that quantity, but you can't stop there. Multiply it with the derivative of that quantity. That will be 2. So the answer is negative 2 sine 2x. If y equal to cos of 2x, then dy by dx is negative 2 sine of 2x. Alright, let's practice a few more of these. Alright, we have f of t equal to sine pi by 4t. Look at the quantity there. pi by 4t. The derivative of a sine quantity is cos of the same quantity multiplied by the derivative of that quantity. So your f prime of t will be cos of the same quantity multiplied by derivative of this quantity. What is derivative of pi by 4t with respect to t? The derivative of 2t with respect to t is 2. The derivative of pi by 4t with respect to t is pi by 4. So that will be pi by 4. The answer, therefore, is pi by 4 cos pi by 4t. Alright, quickly tell me, if f of x equal to sine of mx, what is f prime of x equal to? It will be cos of mx times the derivative of mx, which is m, which will be m cos mx. Right? Okay. Alright, we've got one more difficulty level here. F of x equal to cos squared 5x. There are two chain rules in here. First of all, it's the square of a quantity and cos squared of a quantity. Now, deal with cos squared quantity first. What is the derivative of a cos squared quantity? Well, that will be, remember, a cos squared quantity, the power. It will be 2 cos of 5x, is that right? 2 cos of 5x times the derivative of the quantity. The quantity is cos of 5x. What is the derivative of cos of 5x? The derivative of a cosine quantity is negative sine quantity. The derivative of cos of 5x will be negative sine 5x, it's not finished yet, times the derivative of 5x, which is 5. You see that chain going on? Cos squared 5x. The derivative is 2 cos 5x times the derivative of cos 5x, which is negative sine 5x times the derivative of 5x. And what is that equal to? That would be 5 times 2, 10 with its negative sign, negative 10 cos of 5x sine of 5x. That is the result there. Let's try one more of that type. Say f of x equal to sine to the power of 5 pi x. Alright, what's f prime x equal to? You can now tell me. Apply the power rule first. It'll be 5 sine to the power of 4 pi x times the derivative of what? Derivative of sine pi x. The derivative of sine pi x will be cos of pi x times the derivative of pi x, which is pi. You've got to think in that chain. So that will be 5 pi sine to the power of 4 pi x cos of pi x, and that's the result. Okay, how about this? F of x equal to tan pi over x, tan of a quantity. The derivative of a tan quantity is secant squared of that quantity times derivative of that quantity. So that will be f prime of x equal to secant squared of pi by x times derivative of pi by x. Now remember, pi is a constant, and we did a number of those earlier. Derivative of a over x is negative a over x squared. The derivative of 1 over x is negative 1 over x squared. The derivative of pi over x is negative pi over x squared. So multiplied by negative pi over x squared. So our result is negative pi over x squared secant squared pi over x is the derivative of tan pi over x. But you need to understand this process. Then you will enjoy. You can actually do a number of these, which will really be a pleasing experience once you understand it. Now let's practice some more of these from the PowerPoint that I have provided. Look at this. The derivative of sine of 2x is cos of 2x times 2. That's something that we talked about already. That would be 2 cos 2x. The derivative of sine 2x is 2 cos 2x. The derivative of cos mx. The derivative of a cos quantity is negative sine quantity, negative sine mx, times the derivative of mx is m. That will be negative m sine mx. The derivative of sine squared x. Look at this. Sine squared x, a sine quantity. The derivative is cos of the quantity times the derivative of that quantity x squared, that is 2x. So that will be 2x cos x squared. How about the derivative of cos omega t? Here the quantity is omega t. The derivative of a cosine function is negative sine of the quantity times the derivative of that quantity. Derivative of omega t is omega. So that will be negative sine omega t times omega. That will be negative omega sine omega t. How about this? Derivative of 5x minus c all to the power of 5. Now here we have the quantity raised to the power of 5. So that will be 5 times the quantity raised to the power of 5 minus 1 multiplied by the derivative of that quantity, derivative of 5x minus c. C is a constant. The derivative of 5x minus c is 5. And so the answer is 25, 5x minus c raised to the power of 4. And now a square root quantity. Look at this, d by dt of square root of t squared plus 2t. The derivative of a square root quantity is what? Can you say that on your own? The derivative of a square root quantity is 1 over 2 square root of that quantity multiplied by the derivative of that quantity. So it will be 1 over 2 square root of that quantity times the derivative of this quantity, 1 over 2 square root t squared plus 2t. And what is the derivative of t squared plus 2t? Derivative of t squared is 2t, derivative of 2t is 2, and that will be 2t plus 2. And that will be, put that on the numerator, that will be, factor out at 2. 2 times t plus 1 over 2 square root t squared plus t, and that will be t plus 1 over square root t squared plus 2t. Actually, this summarizes everything we did so far. I want you to practice this some more time. Make sure that you understand this concept well, because we are going to use it as we go on all over. And this is something that we cannot learn now and forget later. All right, tell me, what is this? D by dx of A over U. Well, just be careful there. You know that d by dx of A over x is negative A over x squared. But here it is d by dx of A over U, the derivative of A over U with respect to x. So here U is the quantity, and that will be, well, you know that derivative of A over x is negative A over x squared. So derivative of A over U will be negative A over U squared times the derivative of U with respect to x. So that will be negative A over U squared times U prime, derivative of U with respect to x. D by dx of 5 over x squared plus 1. You can use that result right away here. What will that be? This is our A, this is our U. So that will be negative 5 over square of x squared plus 1 multiplied by the derivative of this. So that will be negative 5 over x squared plus 1 squared. What's the similarity there? Negative A over U squared times derivative of that quantity. Derivative of x squared plus 1 is 2x. Alright, you want to look at this one more time? D by dx of 5 over the quantity x squared plus 1 is negative 5 over the square of that quantity, x squared plus 1 all squared, times the derivative of that quantity, x squared plus 1, that is 2x. And write down the result. That would be negative 10x over x squared plus 1 all squared. How about this? D by dx of sine to the power of mx. Well, this is a simple power rule. The quantity here is sine x. The power is m. So use the power rule. M sine to the power of, what will be the power now? M minus 1. So that will be m sine to the power of m minus 1x multiplied by the derivative of sine x. So it will be m sine to the power of m minus 1x times the derivative of sine x is cos x. And so that will be m. Let's look at the derivative of this one more time, because I had actually a small error in the PowerPoint. Alright, this will be sine to the power of mx. The derivative will be m sine to the power of m minus 1x times the derivative of sine x is cos x. So the derivative there will be m cos x times sine to the power of m minus. Yes, that is the derivative of quantity. Okay, I want you to now take some time and practice a few questions on your own, because only practice makes it perfect. Okay, I want you to stop the video now and find the derivative of these quantities on your own. The first is f of x equal to sine cube x. It doesn't take a lot of time for you to write down the derivative of that. Alright, do that on your own. And the second one is f of x equal to cos of 4x plus 5 third one is f of x equal to square root of 16 minus x squared. Fourth one is f of x equal to sine squared 4x. If you can do all these without any trouble, I'm sure you have understood the concept in this lesson. Okay, let's do a problem. Find the derivative of x squared over square root of x squared minus 9. Well, we've got all those ingredients in here. First of all, this is a quotient, so you need to use the quotient rule. What's the quotient rule again? The quotient rule is denominator multiplied by derivative of the numerator minus numerator multiplied by derivative of the denominator all over square of the denominator. All right, let's practice that. So we have the quotient rule and the chain rule because square root of a quantity. All right, dy by dx equal to, follow this step, denominator, this is the denominator, times derivative of the numerator minus numerator times derivative of the denominator divided by square of the denominator. Well, most of these you have no trouble. This is where the chain rule is going to be applied. All right, what is derivative of x squared with respect to x? That'll be 2x. Let's talk mentally first. What is derivative of square root of this quantity? Now remember, talk about this many times. The derivative of a square root quantity is what? 1 over 2 square root of that quantity times the derivative of that quantity. So the derivative of square root x squared minus 9 will be 1 over 2 square root x squared minus 9 times derivative of x squared minus 9. Let's write that down. So that will be square root x squared minus 9 times derivative of x squared is 2x minus x squared times derivative of the square root quantity is 1 over 2 square root of x squared minus 9 times the derivative of x squared minus 9 is 2x divided by, when you square a square root quantity, the square root will go. So the denominator is now x squared minus 9. Okay, let's simplify this. Now, what does this now become? Can you simplify that? Here, the 2 and 2 on the numerator will go. So this quantity is actually x cubed divided by this quantity. So this becomes 2x square root x squared minus 9 minus x cubed, x times x squared, x cubed over x squared, square root x squared minus 9 over x squared minus 9. And now what we need to do is simplify this. All right, I hope your algebra is good enough to do that. Just watch me for a second to give you an example here. Now, look at this. What is b minus a over b? If you want to do this, take b as the common denominator, and the numerator then will be b squared minus a. Is that right? So b minus a over b will be b squared minus a all over b. So how would you do this like that? Square root x squared minus 9 will be the common denominator. And when you do that, look at this. B minus a over b. On the numerator, this b and b multiplied. Similarly, on the numerator, square root x squared minus 9 will multiply square root x squared minus 9. Is it okay? All right. Let's go and do the next step then. Let's simplify this. I have put the braces here showing that we're going to simplify that. So take x square root x squared minus 9 as the common denominator on the numerator there. And that becomes, when this is the common denominator, remember, this will multiply over there. So that will be 2x square root x squared minus 9 times square root x squared minus 9 minus x cubed over that denominator divided by x squared minus 9. I hope you understood this. And now in the next step, these two together will be the denominator. Is that right? Well, I hope you know all these simple algebra like this. This is something like A over B all over C. A over B all over C will be A over BC. And that's what we're going to use in here. So when you simplify this, it is going to become, these two are going to combine to become the new denominator. Look at that, x squared minus 9 multiplied by square root x squared minus 9 become x squared minus 9 to the power of 3 over 2. X times square root of x is x to the power of 3 over 2. X squared minus 9 times square root x squared minus 9 is x squared minus 9 to the power of 3 over 2. And these two square root quantities get multiplied, the square root goes away. I hope you understand that. And now simplify the numerator by multiplying and simplifying. That will be 2x cubed minus 18x minus x cubed over x squared minus 9 to the power of 3 over 2. And one more step. 2x cubed minus x cubed is x cubed minus 18x over x squared minus 9 to the power of 3 over 2. A very typical problem that you need to be familiar with. So I'd like you to practice it and let me know if you meet any difficulty there. We will have a discussion on what your difficulty is. Just one more problem before we finish this lesson. Find the equation of the tangent line. A very common problem that we do, is that right? For f of x equal to 1/3 x times square root x squared plus 5 at the point 2, 2. To find the equation of the tangent line, we need the slope of the tangent line at that point. So we need to find the derivative of this function at x equal to 2, and that will be the slope of the tangent line at x equal to 2. All right, let's find the derivative. F prime x equal to, remember, this is a product, so you need to use the product rule. And I want you to keep in mind that this 1/3 is a common factor, or we can, what I have done is I have taken 1/3 x as the first quantity. Remember, our power rule is when you have two functions, g of x and h of x. It is the first function times the derivative of the second function plus the second function times the derivative of the first function. So let's take 1/3 x as the first function and square root x squared plus 5 as the second function. So it will be the first function times 1/3 x times derivative of the second function, derivative of square root x squared plus 5, plus second function times derivative of the first function. All right? And the only trouble here will be to find this derivative of this square root quantity. All right? Bring back your understanding of derivative of a square root quantity. Derivative of a square root quantity is 1/2 square root of that quantity times the derivative of that quantity. All right, let's write down that. It'll be 1/3 x times derivative of square root x squared plus 5 is 1/2 square root x squared plus 5 times the derivative of x squared plus 5 is 2x plus square root x squared plus 5 times derivative of 1/3 x is 1/3. Now, in a problem like this, you don't really need to simplify any further. You can put x equal to 2 in here and find the value. But just for practice, let's simplify this anyway. How do you simplify this? First of all, 2 and 2 there will cancel. And what is this term? If you look at this, that term has x times x squared on the numerator and 3 square root x squared plus 5 on the denominator. Is that right? So that will be x squared over 3 square root x squared plus 5 plus square root x squared plus 5 over 3. And now, what's the derivative? We want the derivative at x equal to 2, and that will be the slope of the tangent line at that point. Replace your x by 2 all over and find the value of this. Do that on your own and see whether you get 13/9. So you got the slope of the tangent line at x equal to 2 is 13/9, and the point we know. The point is 2, 2, x1 equal to 2, y1 equal to 2, and the slope m equal to 13/9. Write down the equation of the line. What is the form of the equation? Y minus y1 equal to m times x minus x1. Your y1 is 2, x1 is 2, m is 13/9. Replace all that and then simplify. What do you do there? Now, you can see, take that 2 to the other side. Y equal to 13/9 x minus 2 plus 2. Distribute that and then simplify and see whether you get this. Y equal to 13/9x minus 8/9. Now remember, the lesson that we did now is a very important lesson which is going to be used widely as we go on. So you need to actually go back and do some of these and do all the homework and get back to me if you have problems. You need